Assalamualaikum warahmatullahi wabarakatuh. My name is Kinana. Today I would like to present about our hydraulic project section 1 and we are from group 2. So here is our information. Me, Kinana bin Wakaha, the matric number DF210078. So today I would like to present about the introduction of our project. In Malaysia, flood is very common to hear. Usually many places in Malaysia had been flash flood due to the lack of drainage system. According to research, there are many ways to describe flash flood, commonly referred to as storm-driven flood. According to research, flash flood impact in Kuala Lumpur, high precipitation flow and a brief warning period are characteristic of a flash flood. Since this flood typically claim many lives, typically strike without caution, they impact negatively on infrastructure, decimate ecosystem and claim many lives, all of which have a negative impact on local economies and quality of life. So in this project, the main reason flash flood had been happened in part of Taman New City, Parit Raja area is because of a drainage system is not well. As shown in the research, for example, consequences of a flash flood in Kuala Lumpur have also been caused by poorly maintained buildings which block drains. So to prevent this issue continue happen, national method and many method had been used to propose new drainage system in Taman University Parit Raja. In water resources, the Manning equation is a commonly used and very adaptable formula. The rational method compute the peak runoff rate from a period of uniform rainfall intensity using an empirical linear equation. Importantly, the rational method can only be used to calculate peak runoff rates.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris Mifzal bin Abdul Halim and I will share about the methodology of our group project. So for the methodology, I have determined to divide the methodology part into two parts, which is off-site and on-site. So during the on-site works, what we do is we went to the drainage, which is at the Taman University. We go and take the photo around it as our progress photo. Next, we also measure the width of the drainage and the depth of the drainage. For the length of the drainage, we couldn't done it there because the length is too long, which is 498 meter. We measure it by using the Google Earth. Next, for the offsite works, first, what we do during the offsite work is we will calculate it using the rational method. So for the first element in rational method is we design the RE. To determine the value year of RE, we will determine it using the MASMA second edition. So by follow the quality design storm REs. Next, for the catchment area, we determine how many catchment area we want around the drainage. We can determine whether we want 3 or 4 area. Then when we want to calculate the total area, the area of each catchment area of the small catchment area will be summed up. Next, for the runoff coefficient C, it will be determined by observing the land use around the drainage. When we observe the land use of the drainage, we can refer it in the MASMA second edition also. So next, we will calculate the rainfall intensity. So we will calculate it using the formula I equal to delta T to the power of K divided by D plus theta to the power of K. So for the last one, we will calculate the Q peak, which is the flow. So we will calculate it using the formula Q equal to CIA over 360. So that's all from me. Thank you.
Good day to everyone. My name is Joyce Inya Anak Jos, and for today I would like to explain regarding the analysis of drain that we have found in Taman U by using the rational method. The first step is to select the design RE, which is the annual intensity rainfall, which is 50 years. We have referred based on the MSMA second edition in table 1, which is the commercial and business center, which minus system for the minimum RE is 10 and for measure system is 100. We have found the average to be 50 years and we have taken 50 years for our drain. Next is regarding the drain specification. when we do our survey in the Taman U drain, we have found that the drain have 1.8 meter of drain depth, and also for the width is 2.18 meter. The slide shows the drain drawing specification, which the bottom width is 1.5 meter. From there, we have found the area of drain to be 3.312 meter square, and the perimeter of drain is 6.185 meter. The third step in this rational method is to find the details of catchment area. By using Google Earth, we have found that there are several catchment area that is near to the drain. So we have chosen 4 catchment area which is nearby to our location. We have found that the catchment area is 29.43 meter. Then we are required to find the friction slope. Still, by using Google Earth Pro, we have found that the highest slope is 10 meter, the lowest slope is 8 meter. And by dividing it to the length of our drain, which is 489 meter, we have found that the friction slope is 0.0041 meter. The fourth step is to select the runoff coefficient. By using the coefficient table in MSMA, we have found that for commercial and business centers and for major system that is more than 10 years RE, it is found that 0.95 is used as the coefficient. By referring to table 4, we have found that the equation of time concentration is TD because we are going to find the drain flow. Therefore, we compute the average rainfall intensity, and we have found that the rainfall intensity is 293.07 meter. Final step will be finding the Q peak, which is the discharge at peak. So, based on the formula that is shown in the slide, we have found that the Q or discharge is 22.76 meter cube per second.
Assalamualaikum, my name is Muhammad Faizi bin Manizam, number matric DF21056. I will explain about consider in conclusion. I will elaborate about the purpose new location, the reason and conclusion for this project. Reason for inundation. The survey found that the location of the drain is densely grass, which is cause clogging and inundation. The drain may also be filled in sediment or clogging with divers due to being undersizing. Therefore, a new design proposal should be implemented, taking into account that the peak flow Q peak should be less than or equal to the Q design. And now I will expose or propose the design for new drainage. The problem of undersizing is addressed is proposal designed by considering a new trapezoidal drain measurement to increase the size. Building a drainage channel with sloping side and a narrow bottom is recommended for steady flow speed as per sustainable sanitation and water management. The proposed design increase the depth of the channel and make the slope slight narrow the axis with the problem. The proposed drainage measure size is shown in next slide. Okay, this is new design. For the top length, we take 2.5 and the bottom 1.5 meter bottom, and for the depth 2.0 meter. After we design, we must find the area for drain. First, we must take area. After we cut the area, before we take the P, we must find the Z first. After we find the Z, we get the parameter of the drain, and we continue the calculation for compute the average intensity rainfalls. With this calculation, we can get the book MSMA. For the selection of fitting constants, we can get the table 3 and lambda, theta, k, and to find T average, the measurement ARI for kita take 50 years. Find the storm during hour, we get 0.615 meter. And TD, we can get 8.8 meters per hour as 0.147 hour. Complete average rainfall density, and we get I 302.78 millimeter per hour. After we get I, we can proceed to compute the DQ design. After we get Q design, we will compare whether Q peak is okay or not. For last, we can conclude the other mitigation measure to prevent inundation. Other mitigation measure will be taken in addition to the proposed design change after full consider of the condition of the drain. The landscape of the drain router will be kept clear by trimming grass and other planter so the routers are not clogging. Finally, the drain may be clogging due to poor condition of drainage system. Contribute the clogging of drain. Therefore, it is important to having considerate on the sizing of drainage as well as maintaining the cleanings of the drain to avoid the inundation and allow good surface flow. That's all from me. Thank you.